second type of elimination that we're going to talk about is E1, which is unimolecular elimination reaction. So a couple little bulleted points to look at here. So in this case, the nucleophile acts as a base. So we need a base present in this, right? What happens here, similar to SN1, is a carbocation is formed. So all those factors that we have to be concerned with SN1 apply here. Things like rearrangements. It's very difficult to separate an E1 and an SN1 reaction from each other. They typically occur at the same time. It is a unimolecular reaction, so the rate law is equal to the concentration of the substrate, really. So it's based on the formation of the carbocation. That's the rate determining step. So let's look at the mechanism down below. We'll hit some of these points as we go through and talk about the mechanism. So for this, let's look at this is what I'm going to call the one-line version. So we'll start off with a carbon here. There's a second carbon. And then let's put up here a CH2, CH3. It's an ethyl group. Let's throw in another ethyl group here. And then let's put a nice, we have to pick a leaving group here, so let's pick something specific, an iodo group. Okay, and then over on this other side, let's put an H atom, another H atom, and then let's toss on a methyl here. Now, I want to point something out to you, and we're going to get practice doing this. So once we're all done with SN2, SN1, E2, and E1, we're going to have to look at the reactions individually. But sometimes the most challenging thing is looking at the reaction conditions and figuring out what type of reaction occurs. And we're going to have to practice doing that. We'll do that in our class. So with this, let's go through. It's a reversible reaction. And let's add in, how about methanol here. So here's what we do. In all of these problems, what we have to do is we have to identify our substrate. So our carbon that's right here, that carbon is a tertiary alkyl halide. Well, what do we know about tertiary right off the bat? We know that SN2 cannot occur at tertiary positions. And then we also take a look at this guy. So that guy right there, this is a weak base. It is also a weak nucleophile. So weak bases are not going to facilitate our help in E2 reaction, right? So what you've done is you've really narrowed your choices, and you've eliminated SN2 and you have eliminated E2. So what remains is E1 and SN1, and you'll get both here. What we're going to look at here is we're just going to look for right now at the E1 mechanism. Okay, and we'll do an example down below that is more real life. All right, so the first step that happens in this is the same first step that happens in your SN1 reaction. So the leaving group just grabs its electrons and heads out of town. So that what we're going to have here is our H. It's the same structure minus the iodo group that's left there. So our carbon, another H, our CH3, carbon, and now we have a CH2, CH3, and another CH2, CH3. And then don't forget to put your plus charge right in there. All right, and then we go through now and we carry out our second step. So CH3, OH, that's going to act as our base, and we're going to grab an H. Now, notice here, because we have this carbocation and because our leaving group has left, there's none of this anti-paraplanar, coplanar stuff that we have to be concerned with as we did with an E2. So we're going to swing around and we're going to grab one of those H's, and that'll give us our alkene here. So the alkene that we're going to get in this case, that's your H, your carbon, your CH3, your double bond, and then here are your two ethyls. So CH2, CH3, and then another CH2, CH3. And then also, we're not writing this right now, but you'd get SN1. And then the other note here too is that you would get cis and trans if possible. It's not in this case, right? So there is no cis trans in that particular structure. So that would be your product, and then you'd get the substitution product in here too. Now a couple little points about this as we go through and look at this. Remember, rearrangement can occur, all of that stuff. First step is the same as SN1, and because of that, they're usually just, they go hand in hand essentially, resulting in a mixture of both the SN1, right, that substitution product, and the E1, your elimination product. Note here that methyl hydride shifts are possible, right? So something that we know from our SN1 discussion there. So we follow Zaitsev's rules too. So most substitute double bonds, the preferred one. And then we get all possible stereoisomers, cis and trans, when applicable, when that's possible, right? So let's look at an example down here below. Let's start off right here. And let's grab this cyclopentane molecule. And again, note here, this is a tertiary alkyl halide. Okay, and then we'll go through on this one. Why don't we use water? Now we also notice here, by the way, that water is a weak base, weak nucleophile. So this combination of things is a pattern that you're going to have to start to recognize. So first step in this, if we were just looking at this, we'd say, okay, well, that's going to be an SN1 and an E1 reaction. So the first step of that is to kick off our leaving group, right? So again, we'll recognize this as an SN1 E1. What that's going to give us here is this carbocation. And then that carbocation, and we're going to carry it down here, can undergo elimination. So we'll do E1 down here, and it can also come up here, and it can do SN1. So I'm just going to redraw it down here below. So down here below, we'd have that same structure, except we're going to be doing an elimination on that route. So we're going to come over here, put a plus charge there, and then we're going to go through with water here, and we're going to take off H's. Now, let's look at this a little bit closer. So the question is, where do the H's get taken off? Well, we have to look at all the beta positions. So remember, that's your alpha position. So over here we have a beta position. Right there's a beta position. That's a beta position too, right? And then also notice up here that that is a beta position. So we have 3 beta positions here. So we can take an H off of every one of these spots. Right, so if we take an H off of this position, we'd grab that H there, and we'd swing around and we would do this. So that would give us an alkene right there. So if we do the same thing on the other shoulder in that ring, we get the same product. So in other words here, if we number this beta 1 and beta 2, so beta 1 is going to equal beta 2 for our product. So we don't want to write that out because it's the same thing. We want to only write out unique products, right? And then the other thing that we can do is we could take, if that's your beta 3, we could take an H off of that top carbon, and we would get, right, if we were to write that out down here below, that's your CH2 and an H there and a plus here. So in that case, your water would swing around and grab that H, and then bam, down here. So that would give us the other alkene, which is this. So we get two alkenes there. So those are your E1 products. Which one is the major of those E1s? Probably the first product, because it is tri-substituted. Right? The second product, this guy over here, is di-substituted. Right now, so that's 2 of our products, but we're not done yet because we have that carbocation, we have water present, so solvolysis can occur too, or the SN1. So that, if we come over here, and I'll use green for that, we have our plus charge right there, We have water. So remember the steps of that reaction. Come around and we do this. Right, that's going to give us, in this case, our oxygen here with a positive charge. Right, and then the last thing that we do there is a deprotonation. So we're grabbing one of those H's and giving us a neutral oxygen. So no more formal charge there. I'll get an extra lone pair on that guy. And voila, that would be our SN1. Right. Now, if we had stereochemistry to consider, then we get a mixture of, enantiomers or diastereomers. So what are the products that we'd write out for this reaction? Unless it's specified that, hey, you only want to do SN1 or only do the E1s here, then technically speaking, you're going to get both sets of products here. So you're going to get what I've circled in the green and what I've circled down here in the blue. So they really kind of just go hand in hand, and they're very difficult to separate out.